Hi, it's Mr. T here, and in this video we're going to go over how to make a standard solution. The standard solution is used during an acid-base titration or other types of titrations to make a solution of an exact concentration. We know the exact concentration of it, and we can use it to try to titrate it against another solution that we don't know the concentration of. So to make a standard solution, the first thing that we need to have is an accurate balance or a set of scales. The set of scales should measure to at least 2 decimal places. So here we've got the electronic balance. The next thing that we need is we need to have a funnel, and we place that on top of a volumetric flask. Now, volumetric flask is a specific type of glassware that has the majority of the volume of liquid contained in the bottom part of the vessel and a long skinny neck. There is a line etched up somewhere along the neck. It's often scratched into the glass. That is the specific line that is used to measure the exact volume of the flask. In this case, for this flask, the line would mean that if we filled the liquid exactly up to that line, we would be adding 250 milliliters to the flask. And that's 250.00 milliliters. So it's actually recorded very accurately. So as well as that, we're going to need a washing bottle. So now we've got our glassware, we've got and our balance. We're going to also need one other thing, is a small beaker. The small beaker is what we're going to do to put our standard into to measure it out. So you need to have those 5 pieces of equipment, and you can carry out making your standard solution. We have to, let's go to the next slide. Okay, so first step, take our balance, place onto our balance our small clean dry beaker. Then we're going to press 0, or sometimes it's called tire, on the balance, and the balance will go to 0. We're now going to measure the mass of the solid that we need to make up the exact concentration in 250 mils. So we would have been given an approximate amount that we have to measure. So here it's 1.3 grams, but this balance measures accurately to 2 decimal places, and we don't have to measure exactly 1.3 grams. We have to measure something approximately, or about 1.3 grams, but we need to measure it accurately. So we place the solid into the beaker and we record the measurement. Now see now that the measurement is 1.27 grams. So that is approximately 1.3 grams. So we don't have to get it exact, but we're going to record accurately exactly what it is. So the amount of solid in this beaker now is 1.27 grams. We record that to 2 decimal places, and we make sure we write the unit down. From this, we can calculate how many moles are now in this beaker. Because we know what we've added, the mass, and if we know what the solid is, in this case the solid is going to be sodium carbonate. So we know the molar mass of sodium carbonate, we can calculate the total amount of moles. So we use this equation here, moles equals mass over molar mass. We place the mass in the top of the equation and the molar mass of the sodium carbonate at the bottom, and from that we can work out exactly how many moles are in this beaker. And this is how many moles we're going to now place into a volumetric flask. So to set up to put this in our volumetric flask, we've got our volumetric flask here, which, by the way, we have rinsed with distilled water before we started. We need to make sure there's nothing inside this flask, no other particles apart from pure distilled water or deionized water. Then we put the funnel in the top, and we're going to pour the solid into the volumetric flask. Now, when we pour the solid into the volumetric flask, sometimes small fragments of the solid are still left in the small beaker. So what we have to do now is, this is where we use our wash bottle. We take our wash bottle and we rinse the inside of the small beaker with the wash bottle, and we then pour the liquid that comes out of that into the top of the funnel, and the liquid will drop down into the solid and wash it into the volumetric flask. So what we're doing is we are rinsing all that particles that remain of the solid from the beaker down into the volumetric flask. We also will rinse around the edges of the funnel to make sure no solid is kept there as well, because we need to make sure every single piece of solid, all of that 1.27 grams is placed into the volumetric flask. So then what we do is we add distilled water until we have the volume of water sitting just the bottom of the meniscus of the water, sitting just on top of the etched line of the flask. So we've now added a total volume of water and solid to this flask of 250 milliliters. We're now going to stopper that flask, and we're going to shake it to make sure all of the solid dissolves. We'll then look at the flask again and make sure the meniscus is still sitting on top of that etched line. Sometimes if you want to make sure you get this etched line perfectly, the meniscus sitting perfectly on top of the etched line, you wait till the meniscus, you fill it up just below the line, and then you take a Pasteur pipette and you drop one drop at a time until the line sits perfectly. That will give you the most accurate results. So we remember from the previous slide, we worked out the amount of moles of sodium carbonate we added to this solution. Now what we can do is we can take the amount of moles that we have, and now we take the volume of the volumetric flask. Take care, the volume of the volumetric flask needs to be converted to litres instead of milliliters. And if we want to convert the volume to litres instead of milliliters, we divide the milliliters by 1,000. So I'm going to take this moles of sodium carbonate and divide it by 0.250 litres. That's 250 milliliters. Once we finish that calculation, we work out the exact concentration. We then put a label of the exact concentration and what the solution is onto the flask. This is now a standard solution. That is, we know we have standardized its concentration. We know exactly what its concentration is to 3 significant figures. These are the steps we need to carry out in order to make or to produce a standard solution. Remember, in these calculations, we were using the standard sodium carbonate, which then could go on and be titrated with acidic solutions to carry out a titration. Well, I hope this has been helpful. This videos. Look out for the next one. We will go through the technique on how to do pipettes, and the one afterwards that talks about how to actually carry out the titration. Don't forget, if you find this useful, just subscribe and follow, and you will be notified if I put up another video on this type of thing. Thank you.